Moving on the logs unit, we're going to be working with some of the properties of logs, and maybe you'll recognize it, maybe you won't. We'll talk about it a little bit further, but the logs are so closely related to powers, so the log rules are going to kind of mimic the power rules. They share some of those properties. And so if I am multiplying a log, I have a base in here, base A, and I'm multiplying these two things together, it translates to an addition problem. You may recall seeing that if I had a to the x times a to the y, it was a to the x plus y. So that's its counterpart. Multiplication equates to addition. You don't have to write that down, but I just wanted to, kind of get that, show you that that's how it works, or how they're related to each other. Likewise, division relates to subtraction, and we saw that as well. If I had a to the x over a to the y, that was a to the x minus y in the power. Remember, the log, the answer to a log is a power, and so that's why this is a power minus a power. That's why I have a power minus a power in my exponential rule. Again, I'm getting kind of scrunchy in there, and I don't want to booger it all up too much, but I just want to again show that connection. And then the last one, actually we have two more after this, but these are the main ones that we work with. If I have a power on, remember the answer to a log is a power, so this is like a power on a power. You end up multiplying the powers together. So if we had a to the x to the y, that would be to the y, that would be a to the xy, and that's that connector. So again, those power rules and log rules are very closely related, or those properties are very closely related. We have two additional properties that we're going to look at as well, but before we do that, I just want to go through an example of what I mean. And it works as long as the logs have bases. So remember, if you don't see a base on the log, we assume that that's a base 10. And what I'm going to do here is expand this using the rules. So this is how it works. This power goes out front, so that's 2 times the log of, I'm going to put parentheses on this because I've got parentheses in there. I'm going to expand that out. It's the log of x times y, which becomes x plus the log of y, and then because it's divided by z, it's minus the log of z. So 2 times the log of x plus the log of y minus the log of z. So what I'm doing is I'm bringing a log throughout those and equating that multiplication to addition and division to subtraction. Powers go out in front. I can also simplify with logs as well. So I'm going to do this one in more of a step-by-step. This first part would be ln x to the fourth, that multiplication comes, plus ln y to the third, those are in parentheses, minus ln z. Once I have all those logs in, I can put it together. This is ln, just one, x to the fourth times y to the third over z. That would be my simplified form. When I go from simplified to expanded, this is expanded form, expand to simplified using the properties. The two more that we have are if I have a log base a of a, where the number that I have next to the log matches the base. If you just think about it, it's what power do I put on a to get a? That should be 1. And the other one is log base a of 1 is what power do I put on anything to get 1? And that one is 0. And so those are the two additional sort of extra rules. It's not a property of simplifying, it's just a fact of logs. A to the first power is a, 7 to the first power is 7, a to the 0 power is 1, 10 to the 0 power is 1, whatever, it doesn't matter what the base is. If it's of 1, it will always be 0. So now we're going to take these properties and we are going to be simplifying without a calculator. Don't be afraid. The math is not too bad. What we just have to recognize is a way to rewrite the problem that's given using the information that we have up here. So like this part here is the given information. And I want to write the log base 7 of 60 using a combination of the things up here. Now, you're not always going to use them all, and you may on occasion add one of these equaling 1 or equaling 0 logs to it. So I could add to this that the log base 7 of 7 is 1, and the log base 7 of 1 is 0. And maybe I'll use those to help me. But right now, I can see that I can do 10 times 6 to get 60. So I'd write this as the log base 7 of 10 times 6. Well, that multiplication, oops, I'm pointing up here, that multiplication equates to an addition problem. So what I'd do is I'd rewrite this as the log base 7 of 10 plus the log base 7, log, that looks funny, of 6. And then I have those values. So the log base 7 of 10 is 1.2, and the log base 7 of 6 is 0.9. And now I just have to add those together. 1.2 plus 0.9 is 2.1. That's my final answer. Now, if you took your calculator and plugged in the log base 7 of 60, that's the log of 60 divided by the log of 7. Remember how we did that yesterday, log of 60 divided by the log of 7, or ln 60 divided by ln 7. You should get something really close to 2.1. But we're just practicing the properties of logs today. So I don't want you to depend on your calculator for any other reason other than to check to see if you're close. It's not going to be exact, but it should be really close to what your calculator answer gives. But our goal, again, is to kind of play around with the numbers and see what we can come up with. So on this particular problem, the next one is the log base 4 of 81. Again, what I want to do is try and rewrite using what I have, or if I need to, I can do the log base 4 of 4 is 1, and the log base 4 of 1 is 0. If I need to add those on, I will. But it looks like I can use just this second one here, because I can write this as the log base 4 of 9 squared, because 81 is 9 squared. And then I would put that 2 in front, 2 times the log base 4 of 9, or I'd rewrite that as 2 times 1.6. When I do the math, I get 3.2, 1.6 times 2, and that would be my final answer. Again, you can check it, log of 81 divided by log of 4, or ln 81 divided by ln 4, and you should get something very, very close to 3.2. Moving on to the next, we have a fraction, and it is 5/7. And first you look at this and you think, oh, that doesn't look so bad because I have just two numbers that can't really be broken down or whatever. But then when I notice here, I don't have log base 5 of 5. But remember, we have those other two that we can add. So I can add to this, the log base 5 of 5 is 1. So when I set this up, I can write this as the log base 5 of 5 minus the log base 5 of 7. Well, the log base 5 is 1. Log base 5 of 5 is 1. The log base 5 of 7 is 1.2. Then I do my subtraction. 1 minus 1.2 is 0.2. And again, that's my final answer. Oops, and it's negative. Almost messed that one up. Sorry about that. Likewise, in the next one, I don't have a log base 5 of 1. But remember, that's another one that we can add, one that will show up. I could write this as log base 5 of 1 is 0. So when I break this next one down, it's the log base 5 of 1 because it's division, minus the log base 5 of 7, and I would have 0 minus 1.2, and my final answer would be negative 1.2 on that one. Again, just using the rules, some are going to be more difficult than others. Some are going to be require maybe doing a little bit of a breakdown of something, so maybe we have to think a little bit when we do this. When I move on to the next one, I have a combination of stuff going on in here. Log base 1 over 100. Well, I'm going to start by rewriting this. Sorry, log base 6 of 1 over 100. Log base 6 of 1 over 10 squared, because 100 is a perfect square, and I see up here that I have 10. It's not necessarily the only way to do it, but it's a way to do it, and it's the way I'm going to go with. And then I'm going to break this down into, remembering that log base 6 of 1 is 0. I'm going to break this down into log base 6 of 1 minus log base 6 of 10 squared. So log base 6 of 1 is 0 minus 2 times the log base 6 of 10, because that's how the power comes out front. So this becomes 0 minus 2 times log base 6 of 10 is 1.3. So I'll end up with negative 2.6 for my simplified answer on that one. Occasionally, I'm also going to have another situation that happens that maybe I have to do a little bit of work or adjusting. And if I look at this, I think, okay, this has nothing to do with log base 5 of 5 or 1. I don't see any of those in there. I see 3 halves. I have 7, 12, and 8. None of those numbers are up there. So then I'll start playing around with what I have. And one thing I can recognize is, all right, 12 and 8 look familiar to me. What if I put 12 over 8? Does that reduce down into 3 halves? Divide the top by 4, the bottom by 4? It sure does. So sometimes you're going to have to play around with it. And so 12 eighths I recognized as equivalent to 3 halves. So I'm just going to write this as the log base 5 of 12 eighths. And then I can break it down again, log base 5 of 12 minus the log base 5 of 8. Log base 5 of 12 is 1.5 minus 1.3, and 0.2 again is my final answer. The thing again that I want to stress here is I want you to try to work with these values here instead of working on your calculator and plugging it in. And I can tell if you do it on your calculator because sometimes the rounding is a little bit off. So please make sure that you try and practice the manipulations. It helps you with the properties as well as just some even basic math skills, refreshing perfect squares and things like that. All right. Up next, we're going to be solving log equations, and that'll finish out our day. When you solve log equations, you are going to also apply the properties. We have 2 different methods of solving. Method number 1, get the equation to the same log on both sides. And only one of them. So I'm going to have a log base a of x equals log base a of y. And then what I can do if it's the same on both sides is I can just drop the logs. And then I end up with x equals y. The other method is if I get the equation to 1 log, that's a 1, on one side, that's a 1 as well, 1 log on one side, then I can rewrite in exponential form. To solve that way. And so what that would look like is I have the log base a of x equals y, so I have 1 log, and then I can write it in exponential form and solve. So that's a to the y equals x. And then that would be a method to solve those equations. So the 2 different options are get it to 1 log on one side, 1 log on the other side, and then drop the logs, or get it to 1 log on one side, and write it in exponential form. So if you look at this first one, I have log base 19 of x plus 9, log base 19 of 2x plus 2. Because I have 1 log on each side, I'll just write x plus 9 equals 2x plus 2, and then I can go ahead and solve. Just like a regular equation, I minus x, so 9 equals x plus 2. I minus the 2, so 7 equals x, and then that's my solution to my equation. Next one is just like that, very similar. 3p minus 6 equals 2p plus 9. Solve, I get p minus 6 equals 9, add the 6, p equals 15, and I'm done with that. I do have to be careful and check my answers sometimes in there, because I cannot have, we talked about this yesterday, I cannot have a log of a negative number. So if it's anything that makes this negative inside of there, I'm going to I have no solution, and that can sometimes happen as well. On the next problems, I have 2 logs on one side and 1 log on the other side. So again, I'm going to do, or not again, but now I need to do some cleanup before I can do the solving. So I'm going to rewrite this. Addition equates to multiplication. So this is the log base 2 of x times x plus 4 equals the log base 2 of 5. And so once I'm there, then now that I have it as 1 log, I can drop that. X times x plus 4 equals 5. And I have to distribute that through and set it equal to 0. Here comes that factoring to solve again. We've been doing so much. I go ahead and I factor. This would be x plus 5x minus 1 equals 0. So x is 5 and x is, negative 5. Yeesh. Sorry about that. X is negative 5 and x is 1. This is where I have to go back in and check. Can I put a negative 5 in there? Can I raise 2 to any power that would give me negative 5? And I can't. So negative 5 is not an option, and x equals 1 is my only solution for this particular problem. So I had to get it, simplify it, so I'm down to 1 log, then I can drop the logs and solve, and then I have to go back to some of my algebra days. On problem number 10, you'll see that I only have logs on one side, but I'm still going to need to simplify this. So this is the log base 8 of x plus 1 over x, because it's minus equates to multiplication, equals 1. And so now I only have the 1 log. I'm going to write this in exponential form and solve. That's 8 to the first power equals x plus 1 over x. So 8x equals x plus 1, 7x equals 1, x is 1/7 would be my final. Does that work here? Is that going to cause a negative value? Nope, not an issue, so x equals 1/7 is a fine answer. Down to my last 2, I've got log. Again, notice I don't have a number on the bottom, so remember I know that this is log base 10. And so I'm going to rewrite this as the log of x over x plus 3 equals 1. Again, it's log base 10. I only have a log on one side, so I do 10 to the first power equals x over x plus 3. So 10 times x plus 3 equals x. Just doing algebra. Go ahead and I'll solve. 30 equals negative 9x. And so x is 30 over negative 9. X is, when I simplify that, negative 10/3, I'll write it. I'm going to go back up here and see if it's going to cause a problem. Negative 10/3 is going to cause a problem, so I have no solution for this particular problem. It can't be solved. There's no way. Oh boy, I'm sorry, I didn't even have my work showing. Because it ended up being, and I just want to double check, 10x plus 30, I'd end up with, yep, a negative value, and yep, can't have a negative log. It's going to cause an issue there. So again, no solution. That one's not going to work on this problem. My last one deals with the natural log. The natural log is a log with a base of e. So when I'm working through and I want to simplify, let's say I needed to drop the log or write it in exponential form, I would have to write it as e to some power equals something. But in this one, I'll just follow my rules. I've got that squared on there, so this is ln 9 plus 2 times ln 5x, the power comes out front, equals ln 80. Then that addition is ln 9 times 5x equals ln, sorry, I have got to adjust that. Okay, I need to leave that power on there right now. I'll put that there for now, and it's only on the x squared. Okay, I can't do that. I can't bring that power down. I wasn't thinking there for that moment. Sorry about that. So this is going to be ln 9 times 5x squared equals ln 80. And then I have ln 45x squared equals ln 80. I'm down to just the log, so 45x squared equals 80. X squared would end up equaling 80 45ths. So when I simplify that, I get x squared equals, I can divide by 5, so I will have 16 ninths, looks like. And so when I take the square root of both sides, x is plus or minus 4/3. Again, I have to go back up here. Is plus or minus 4/3 going to cause a problem? Nope, because I'm going to end up squaring it. So my final answer is plus or minus 4/3. So again, you want to use your power rules to get it to a point where you can simplify it, and then once you're able to either write it as exponential or drop your powers or drop your logs on both sides, then you can just solve it using algebra. As always, if you have any questions, please let me know. Otherwise, I will talk to you soon.